Asteroid Apophis, a sizable celestial body, is projected to make a close approach to Earth in 2029. Its sheer size exceeding the dimensions of several football fields and possessing a mass greater than numerous skyscrapers underscores the potential devastation of a direct impact. The asteroid's name, derived from the Egyptian god of chaos and destruction, aptly reflects the potential danger. While scientific predictions indicate a low probability of a collision, the potential consequences of such an impact are enormous. This close encounter serves as a stark reminder of the inherent dangers in space and the ongoing need for vigilant monitoring and research. The sheer size and proximity of the asteroid Apophis highlight the significant threat posed by these celestial bodies. This section introduces the imminent threat and potential danger of a large asteroid impact. A recent asteroid explosion over Russia, albeit small, highlights the challenges of detecting and predicting these celestial events. The 2013 event, a larger incident, demonstrated the devastating potential of relatively small asteroids entering Earth's atmosphere at high speeds. Even a small asteroid can create a powerful atmospheric explosion, capable of causing significant damage. The 12-hour warning before the December 2024 event underscores the limitations in our current ability to predict these events. This section emphasizes the current limitations in asteroid detection and prediction, highlighting the need for enhanced technologies and international collaboration to improve our preparedness for similar events. The 2013 event serves as a critical reminder of the ongoing threat posed by these celestial bodies. Simulating a hypothetical asteroid impact on Los Angeles reveals the catastrophic potential of such an event. The results, encompassing massive cratering, widespread fires, and destructive shockwaves, illustrate the potential for devastation. The simulation models the impact's immediate and long-term effects, highlighting the potential for loss of life and infrastructure. This section serves as a cautionary example of the immense scale of destruction possible, emphasizing the need for preparedness in case of an actual impact. The visualizations underscore the profound consequences of a large asteroid impact on a populated area. The 2013 Russian asteroid explosion, while thankfully not directly impacting the surface, yielded critical insights into the destructive potential of these celestial events. The low impact angle, around 20 degrees, allowed significant atmospheric dissipation, preventing a more catastrophic impact. However, a steeper angle, closer to 45 degrees, would have resulted in a much more destructive impact, potentially triggering widespread devastation. This section underscores the importance of impact angle, emphasizing how even relatively minor changes in trajectory can significantly alter the outcome. The 2013 incident highlights the crucial role of atmospheric interaction and the varying degrees of potential damage. Detecting asteroids, especially those hidden by the sun's glare or traveling within the inner solar system, presents a significant observational challenge. The difficulty stems from the vastness of space and the limited ability to continuously monitor potentially hazardous celestial bodies. This makes early detection crucial, as intervening to alter an asteroid's trajectory requires significant lead time. The inherent difficulty in spotting and tracking asteroids, especially in challenging locations, underscores the limitations of our current observational capabilities. This necessitates the ongoing development of new technologies and strategies for more comprehensive and continuous asteroid surveys. The Tunguska event of 1908, a large explosion over Siberia, serves as a stark reminder of the devastating potential of an asteroid impact. The explosion, estimated to be thousands of times more powerful than the Hiroshima bomb, flattened millions of trees. This historical event illustrates the destructive force of an asteroid, even a smaller one, when it reaches the Earth's surface. The relatively low population density in the impacted region prevented a greater loss of life, but the event still underlines the potentially catastrophic nature of asteroid impacts. This section highlights the devastating consequences of asteroid strikes on populated areas. NASA's DART mission, successfully redirecting the asteroid Dimorphos, offers a crucial step toward planetary defense. This demonstration proved the feasibility of altering an asteroid's trajectory. The mission highlighted the potential for deflecting an incoming asteroid through kinetic impact. By successfully changing the orbit of Dimorphos, the mission demonstrated a crucial method for mitigating the threat of asteroid impacts. This underscores the importance of early asteroid detection and the potential effectiveness of planetary defense strategies. The DART mission represents a concrete step toward a potentially life-saving approach, highlighting a proactive strategy for mitigating the risks of asteroid collisions. Opinion: NASA's asteroid mission to Apophis, key for Earth's defense. On Friday the 13th, yes, really, of April 2029, Earth will avoid an apocalyptic event by an astronomical hair's breadth as the asteroid Apophis streaks by. It will come closer to Earth than the Moon. Much closer, in fact. It will come between us and the satellites that bring us radio, television, and military intelligence. Apophis is named after an Egyptian god of chaos and evil. If it were to hit Earth, chaos would be the least of our trouble. It's 1,000 feet across, the size of a football stadium, and it's going 69,000 miles an hour. Apophis won't hit us. At least we're pretty certain it won't. But it does offer us an historic opportunity to closely observe it and improve our ability to defend against future asteroid threats. Unfortunately, our government is blowing the chance. OSIRIS-REx, Origins Spectral Interpretation, Resource Identification, Regolith Explorer, has been in space almost 10 years, and it has already returned bits of another asteroid named Bennu. With clever rocket science, NASA redirected OSIRIS-REx so that it will catch up with Apophis just days after its closest encounter to Earth. Using the same billion-dollar instrument suite designed for its original asteroid, the spacecraft will be able to closely study the surface, shape, and gravity of Apophis. It's a fantastic deal for the taxpayer. 2 missions for the price of 1, and we already paid for the first one. Now rechristened OSIRIS-APEX, Origins, Spectral Interpretation, Resource Identification and Security, Apophis Explorer, the project needs only some annual funds to pay its science and engineering team. Led by the University of Arizona, this team will prep the spacecraft for its new encounter. The money needed to support the team is far less than the cost of one of the fighter jets that Jim Bridenstine used to fly or that Bill Nye worked on as young engineer. But recently, due to overall budget cuts, much of that modest funding was taken away. If those cuts remain in place, the science team of OSIRIS-APEX will have to stand down. Crucial years of planning and coordination will be lost. We won't learn as much and will be less prepared for future asteroid encounters. There are a bevy of commercial and private sector options that could help too. Instead of reaching Apophis after its close flyby of Earth, they could get there months beforehand. This would allow us to map Apophis in its pristine state before Earth's gravity potentially alters the asteroid. Comparing the before and after maps would provide clues to how asteroids like Apophis are assembled. Vital information if we ever need to deflect one. NASA also has perfectly good asteroid spacecraft sitting on the shelf. The twin Janus spacecraft, originally designed for another asteroid mission, were put in storage, their mission canceled when their parent spacecraft was delayed. These could be easily repurposed and launched toward Apophis within the next few years. Engaging our private space sector in a dress rehearsal for saving the world at little cost to NASA is a no-brainer. But budget cuts may prevent these crucial investments. This is our chance to demonstrate American leadership in the defense of our planet. While we wait for the confirmation of the next NASA administrator, Congress can take action to ensure that NASA has the funding to, at a minimum, support the OSIRIS-APEX mission. When we have new NASA leadership, we urge them to act decisively on this opportunity to leverage small dollars into big, meaningful outcomes for the nation. There are few clearer justifications for public spending than our common defense, perhaps especially from asteroids. Even in our current divided political environment, we are confident this is a topic that unites us all. In fact, as we were writing this piece, astronomers discovered another heretofore unknown asteroid, 2024 YR4. Right now, it's estimated to have a 1 in 71, 1.4% chance of striking Earth in 2032. That might seem like a small probability, but it's not zero. Further observations will likely confirm that 2024 YR4 will miss us. But how will the world react if it is indeed on a collision course? It's a vivid reminder of what's at stake for our species. Kids of all ages love 2 things: space and dinosaurs. It turns out these 2 areas of study are intimately connected, or at least one impacted the other. You know the history. 66 million years ago, a massive asteroid struck Earth, leading to the extinction of the ancient dinosaurs. The ancient dinosaurs did not have a space program, but we do. Let's use it wisely. Asteroid Apophis. Characteristics, trajectory, and risks. The asteroid Apophis has been the subject of great interest and concern since its discovery in 2004. Initially considered a potential danger to Earth, its trajectory has been exhaustively monitored by astronomers around the world. Its approach in 2029 will be a unique astronomical event, generating both expectation and scientific studies to better understand these celestial bodies. Although calculations have ruled out, at least for now, an impact with our planet, the incredible proximity at which it will pass gives us an unparalleled opportunity to study it. Below, we will explore in detail its characteristics, its trajectory, the risks that were once considered, and the space missions that are scheduled to analyze it. Characteristics of the asteroid Apophis. Apophis, whose official name is 99,942 Apophis, is an asteroid belonging to the Aton group, which are those whose orbit is mostly within the Earth's orbit. It is estimated to measure around 335 meters in diameter, making it a considerably large object among near-Earth asteroids. Its composition is mainly made up of silicates, nickel, and iron, which classifies it within the group of asteroids of type Rocky. It was originally thought to be elongated, peanut-like in shape, and its surface is thought to be composed of loose rocks due to its low gravitational force. As for its orbit, Apophis takes approximately 0.9 Earth years to complete one revolution around the Sun. However, its trajectory will be altered after its close pass by Earth in 2029, increasing its orbital period to 1.2 years, the trajectory and its approach to Earth in 2029. The biggest astronomical event related to Apophis will occur the 13th of April of 2029, when it will make its closest approach to Earth. At that time, it will pass just 32,000 kilometers from the Earth's surface, a distance shorter than that of many geostationary satellites. This close pass will allow the asteroid to be observed with the naked eye from various regions of the planet, especially in Europe, Africa, and Asia. Its brightness will be comparable to that of a 3.3 magnitude star, and it will move across the night sky at a speed of 45.080 kilometers per hour. This event will be crucial for the study of the asteroid, as was the planetary security alert in relation to other asteroids that could represent a danger to Earth. Earth's gravity will significantly affect its orbit, altering its future trajectory. Although current calculations rule out an impact with Earth in the coming decades, astronomers are continuing to study how Earth's gravity could alter its course and whether this could pose any risk in the future. Is there a risk of impact in 2036 or 2068? Initially, calculations showed a probability of impact of 2.7% in 2029, which raised concerns in the scientific community. However, more precise observations have completely ruled out this risk by this date. As for 2036 and 2068, the chances of impact have been drastically reduced. In its latest assessment in 2021, NASA confirmed that Apophis does not pose a real threat to Earth in the next 100 years. This is a relief for the scientific community and citizens who care about the safety of the planet.